So in this lecture we will again look at process control block. So in the last lecture we learnt about process. So process is nothing but a program in execution. Okay, and now we will learn that what are the things that we have to maintain your operating system. So it's basically, we know it is running a lot of processes. Okay, so it runs process P1, P2, P3 until Pn. Okay, a lot of processes are running. Now what happens is, these processes, so when they are running, so some of them are running, so one CPU is there, let's say it is running process P2 now. After that it might run P3 and so on. But a process, so when let's say someone is running, so what are the things that are required? So there is, process is a program that is in execution, so it has some lines of code or instructions. So when let's say your operating system, the CPU is executing, so it must have a program counter to know that okay, so CPU is, let's say, a person who is instructed that okay, this is the new instruction that you have to follow. So now for a process, let's say this is at line 9, so it should know that okay, which line it is executing now, so that when next line it has to execute, it will give to the CPU, you execute line 10 or something like that. Okay, so there is a program counter for that. So each process maintains a program counter which will make it remember that okay, till now I have executed these many lines, that next line is what we have to execute, that is stored in the program counter. Process state, so last time in last lecture we talked about process state, that you have a process, so it can be now in the ready queue where it is waiting for the processor to be attached to it. It might be waiting for the input output queue where it wants to access the input output. So that state is also very necessary where it is right now. CPU registers, so all the processes, so when they are being executed, so they store their calculations in the registers. Okay, so they need to know that okay, what were the values now when it was being executed, what are the registers value that are stored. CPU scheduling information, for example, what is the priority of the process and so on. Memory management information, what is the maximum amount of memory that is given for this process. Then accounting information, input output status, that if it's making input output, is it complete or something like that. So all these information needs to be there, so that when the CPU is executing, so these are the things that are going on, so they should be there somewhere, so that even when the processor changes which process it was executing, then when it comes back, I should know that okay, where I was. Okay, so it's something like if you have exam for operating system algorithms, okay, and then let's say what else, database, DBMS. Now you are the person, CPU, who is studying all three. You have exams, no vacation in between. So what you do, so you are studying, let's say, so you should remember that I had studied till page number 196 of OS, and then you switch to algorithm. So you are the CPU, you are studying all the things. You remember that okay, I was in the dynamic programming page number 32, so you will go there and start. Then in DBMS you should know that okay, I am studying something like indexing, and it is in page number 246. So when you are switching from algo DBMS, you will need to know these information, where were you. Okay, and this is there. So this is the importance of program control block for context switching. And so this is shown here, process state, where are you right now, what state you are working on. You are being executed, the process is being executed, is it waiting for some event. Process number, each process, how will I recognize? So like last time you had algorithm, so there was some name to identify, so you have process ID for it. Program counter is there, what page I was studying, so what line of code I was executing. Registers, so what analogy I can give for registers? So let's say in register you store some values, like you were solving some problem in algorithm, okay, and you had few values, and then suddenly you are asked to study operating system. So you will know that okay, you are making a sum, that okay, make a coin change problem or something like that, some algorithm problem you were solving, but in between you just were interrupted to study operating system. So half of the problem you had already solved, so you will try to store the results in your registers. Memory limits, so of course how much maximum memory you can use. List of open files, so the process was actually, it was doing some input output and so on when it was asked to switch the context, and other process was assigned the processor, so I should know what file input output device I was working on. So these are the things that are important, and one example is shown here. So there two processes are running, and then operating system has one processor, it decides which process should be run. So process 0, process 1. So interrupt or system call is there, so executing this process P0 was being executed, then there was an interrupt and now it should stop. So system call, so there was change the schedule and give it to process P1. So now what happens, whatever he was doing, the CPU, that guy will store everything, that okay, I now need to make a context switch, and so store everything in PCB 0, that which line number I was executing, what were the input output files I were handling, and so on, everything stored, so that when I come back I should just look from here and continue. Now it becomes idle for some time, context switch is there, then you reload whatever was there in program process control block 1. So now I remember from here that okay, I had for process 1 I had executed till line number 131. So I will start executing from here. I was in between some calculations, so there are some values in the registers which I will access and all these things. Then again what happens, this executed process P1, then again there was interrupt. Now you should save every state of process P1 in PCB1, and now after that again I want to start process P0, so reload the PCB0. So this way you will have the scheduling or the context switching. But process scheduling, so and context switching, let's see what is the context switching is very important because it allows new processes to be run by the processor, but it is an overhead, okay, because you are switching the context and at that time no work is done for the processes. It is basically a context switch. So next thing that we will see, and I think in the next lecture, is about process scheduling. So we learned here about process control blocks. Okay, so I think process control block, yes, so that is what we studied now. It's very important. So in the next lecture we saw that this is important because we need scheduling of the processes. So next chapter or next lecture we will see what is process scheduling. So thanks a lot. Watch my next lecture, subscribe to my YouTube channel and tell it to all your friends. Thanks.